Emma. Okay, this
According
chapter is electrolysis. So in order to understand this chapter, what we actually have to do is we have to look back at ionic compound. Okay, do you remember ionic compounds?
Oh, no.
Cannot. Okay.
Wait, first, yeah, no.
Okay. I'll briefly go through. Okay. Ionic compound is like this. Okay, let me briefly go through. Okay. I know you'll remember. Ionic compound is the metal, which is group 1, 2, 3, wants to achieve full outer shell. So group 1 will release one electron to become positive 1. Group 2 will release 2 electron to become positive 2. And group 3 will release 3 electron to become positive 3. Okay? So when they release that electron, who gets the electron? The non-metal. The non-metal that we talk about is in group 5, 6, 7.
Isn't it? 7.
Yeah, my brain too fast. Okay, so this one will receive 3 electron and become 3 negative. This one will receive 2 electron and become 2 negative. And this one will receive 1 electron and become 1 negative. Remember? Okay, and then the sodium ion and the chloride ion are attracted to each other by electrostatic forces of attraction, and they become the ionic compound NaCl.
Echo.
Remember? Okay, so the Na will look like this, and the Cl negative will look like this. The outer shell, 1, 2, 3, 4, 5, 6, 7, 8. Okay,
I remember.
remember now? Jay, you remember? Okay. So now, this electron came from the positive, right or not? The positive gave this electron to, so it used to be 281, now it is 28 only, because I gave you 1 electron. And so they fall in love and become ionic compound. Okay?
So cute.
Now, electrolysis is about them breaking up. Electrolysis is how our ionic compound decides that they need to take a break in their relationship and they break up. Okay? Then, so that's electrolysis. Okay. First of all, ionic compound can only conduct electricity in what state? Hmm? Ionic compound can only conduct electricity in what state?
Um,
In?
was it full outer shell? I'm not
No.
sure.
It can only conduct electricity when it's in what state? Ionic compound.
Charged state.
Molten, no, molten or
Oh, molten or
aqueous. Okay, so look at your textbook, page 129.
29.
129. This page. Electrolysis of molten compounds.
Do you like my new pencil case?
My goodness, that's so cool.
Look,
Wow. Where did you get it from?
I don't know. My mom and dad bought. Like,
That's nice. From Korea. That's nice.
my dad's here.
Ah, is it nice having him here?
Hmm.
What did you get from Korea for you?
Like hip
Food?
hop album
Oh my goodness, so cute.
that I ordered.
So cute. Jay, what are you going to bring back from Korea?
Uh, I went to this convention thing.
Isn't that the same thing as you have? No. What's that? Oh, interesting. Oh, cool. What's that? Oh, it's like a plushie, right?
It's
So
like a
nice.
convention. And I also have these figures.
Okay, you're gonna bring it all back home? All back
Yeah,
here?
it's like really cute.
Nice, nice.
His name is Kim Hamji.
Okay, very cute. You better make sure everything can fit into your school bag, your luggage when you come back.
That's
Okay,
why we bring a lot. And we
yeah,
go back with a lot.
yeah. Okay, electrolysis of lead bromide. Okay, so if you notice, this thing doesn't look like a beaker. This thing is actually curved. It's curved because it is a crucible. It's not a beaker, it's a crucible. Crucible is, have you seen crucible before? I don't think so. Wait, let me show you.
Possible.
Crucible.
Wait, isn't the fasting time ended? Like the
No, no, no.
candles?
No, no, no. I'm not fasting as in Muslim fasting. I am fasting like health, intermittent fasting.
Oh,
Ah, yeah, I'm not really
How
diet, but more for health.
fasting.
If I lose weight on the way, even better. Okay. So this is a crucible, guys. Can you see? This is the one you have in your school lab.
Oh,
Okay. Why do they use a crucible instead of a beaker? Because when you want to do molten, the temperature is very, very high. Your beaker will melt. Okay, can I understand? Okay, so why am I muted? Okay, so you take a crucible and here you put lead 2 bromide. So lead 2 bromide is PbBr2. In solid, it cannot conduct electricity. When you make it into molten, the lead ions and the bromide ions are freely moving. Okay? So lead ions are positive. Positive lead ions are called cations. Negative lead ions, bromide ions are called anions. Okay? Now, in electrolysis, we must use electricity. So, this is the electricity. It's connected to the negative terminal is called the cathode. And the positive terminal is called the anode. Okay? So what happens is the positive cations will be attracted to the negative cathode. The negative anions will be attracted to the positive anode. Okay? Now remember they are molten, so they are freely moving. Okay, what are they trying to do? They are trying to return to original. Because now, remember, it is a ionic compound. They are not happy with each other. They want to break up and they want to change back to become elements. So from compound, they want to change back to become elements. And in this compound, you must understand it is Pb2 plus and Br negative. Okay, so Pb2 plus, in order to change back to element, must receive 2 electrons to become Pb. Okay, bromide has to release electrons to become bromine again. So now, is it back to normal, back to original? Yes. Okay. Now, what I'm going to do is I'm going to show you a very simple experiment. Okay, how they do this. Okay, how they do this in the school lab. Okay, wait, I cannot record because electrolysis is the decomposition or it's a breakdown of ionic compound when it's in molten or in aqueous. Why molten or aqueous? Because solid cannot conduct electricity, only molten and aqueous can conduct electricity by the passage of an electric current using electricity. So using this, first you have an ionic compound. The ionic compound must melt. Okay, the positive cation goes to the cathode and receives electron to change back to metal element. The negative anion will go to the anode, and the negative will release electron and change back to element also. Can you understand? Okay, so this definition is very, very important. It's a 3-mark question. Electrolysis is the decomposition of an ionic compound. An ionic compound when molten or aqueous by the passage of electric current. Okay, can you understand? Can? Okay, I gave you this one, right? Okay, we're going to use this. So, Jay, you might want to draw it out. Draw out the table. Okay. Wait, I show you what to do first, I show you what to do. Hold on. Dave, coffee mate. You look for that? Yeah. Okay, bye-bye.
Who was
Okay.
that?
Jay, you might need to use a piece of paper to draw this. Okay,
No, I
okay,
can
let me
pull it into
sorry?
notes. You know, when
Sorry,
you give
sorry.
me something, I can just open it and I just can like
Okay,
move it
okay. If you
forward.
have an iPad to draw, even better. Yeah.
I have a pen for my pen phone.
Okay. If you can do that, even better. Okay, now like this, do you remember all the positive and negative charges? If you cannot
Mm.
remember, you can look at your periodic table or the list of charges that I gave you last time. Okay, so let's start with this. First of all, potassium fluoride is KF, not KFC, KF. So potassium fluoride is KF because potassium is positive 1, fluoride is negative 1. The cation is positive, anion is negative. Okay, so in all these reactions, what happens is I'm doing electrolysis. My electrode is made out of graphite. Why must it be made out of graphite? One side is anode, one side is cathode. This is positive. This is positive. Positive is anode. This one is negative. Negative is cathode. I must use graphite because graphite has high melting point. When I melt the stuff in my crucible, my electrodes won't melt. Understand? That's number one. Number two, it is also inert, meaning that the graphite, the carbon in the graphite won't try and react. Okay? All right, now here I have potassium. In order to change back to a potassium atom, what does my potassium ion do? Does it gain electron or lose electron? Grace? Does this, it wants to change back to become element. So cathode, it will gain electron or lose electron. It already lost electron. Now it wants to change back to original gain. So it will gain back 1 electron. Positive 1 means it already lost electron just now. Now it gained back to form potassium. So from ion, it's now changing back to atom. Changing back to original. Get it? Now fluoride, what will it do? Gain or lose electron? Lose electron to change back to fluorine. Okay, but the problem is, remember the list I gave you last time? Fluorine, chlorine, bromine, iodine, hydrogen, nitrogen, oxygen, all must be double, double, double. Okay, so here I must put 2 fluoride ions, changes back to fluorine gas, and releases 2 electrons. Okay, so my overall equation is I start out with potassium fluoride, ionic compound. It changes back to become element and element. Balance the equation 2, 2. So remember, this is an ionic compound. It is in molten form. I change it back to its element using electricity. Can you understand? Okay. So, please do the rest. Do you understand what I want you to do?
Should I copy this down?
Yes, copy this down first.
Mm.
Wait, but zinc is not.
Zinc is 2 plus. Remember the list? No, it's not transition metal. Last time I gave you all a list to write the ionic compounds, remember?
Oh.
Okay, I give you a clue. Zinc is 2 plus. Zinc is the only one that's different. The rest are all the same. The rest are all from the periodic table. Okay?
So others are all
From
just.
group 1, group 2, you can get from the periodic table.
Do you have white felt?
No. Let's do one by one. So this one, Zn2 plus 2E becomes Zn, correct? Correct. This one Cl negative become Cl2 plus 2E. Correct? Okay. So this one you understand why? You start out with okay, so this one is a little bit different because you want to balance. This one is 3 electrons become Al. Okay. This one is O2 negative. Each oxygen releases 2. So if you want to do O2, you need to release 4 electrons. So that's why the equation looks like this. This one is a little bit special.
This one I get it.
Okay. Now, this one, you start with Al2O3. It becomes Al and O2. This one cannot change. Alright? Because it's O2 and Al, right? Okay, but then you see, here got how many O? You're balancing the equation 3. So you must put 3 here so that it's balanced.
Oh, I
Ah,
can't
you
do
put-
like that.
You're supposed to balance the equation. That's why I said you must write down first, then only balance. Okay?
Wait.
Because you see, you started out, you started out with Al2O3. It must become Al and it must become O2. So
Oh,
after that, only you balance equation. Okay? All right. Can you try the last two?
Al2. Oh,
Okay.
I think I get the hint of it.
You get. Okay.
Isn't it this?
Yes, correct. Because it's already balanced.
Oh, you don't need balancing.
Yes.
Wait, for sulfur?
No need. It's just S.
No, like for the half equation.
So it's just S. 2 negative. So you just receive 2 electrons. I'll release 2 electrons. There's no need to have 2. Sulfur is not gas. Okay, I'll give you 1 more minute, then I'll discuss, okay? You try.
Is it?
No, L it's just Li because it's a metal. Metal only exists as atom. Okay?
What?
Metals only exist as atom. Then atom, you cannot put numbers behind. So J, can you check your answers? Ca2 plus 2E becomes Ca. Br negative become, this one you did correct, right? This one CaBr2 becomes Ca plus Br2. Correct? Okay. Now this one, you got it almost correct. This one correct. Okay, the thing is, you start out with lithium sulfide. You must understand it just becomes lithium and sulfur. So you can only balance the number in front because this is a metal. Metal must always exist as an atom, not a molecule. Can you understand? That's what you make mistake. Other than that, it's all good.
Forget.
Mm. Okay, Jay, you okay? Did you get it correct?
Kind of.
Okay, which one did you get wrong? Do you understand everything? Is there anything you don't understand?
The half equation things
For which one?
for ClO and beer.
For
I didn't
Cl?
put the
She said CL.
Oh, do you know why it has to be 2? Because of this. Because of this list. These guys have to always be 2.
But why are they in front?
What is in front?
Like, why are the twos in front?
Okay. It first, F is an ion. Okay? F is an ion. It releases electron to become atom. It releases one electron. However, F atom doesn't exist. Two F atom will join together. In order to balance this equation, I must explain that two fluoride ions each release one electron to become a fluorine. This fluoride is 2,8. It releases one electron to become 2,7. Another fluoride ion releases one electron to become a fluorine atom. This and this will automatically join together. So all I'm doing is taking these two equations add together. So it is F negative and F negative cannot magically form. Where got such thing like that? Doesn't make sense. This one is this. Do you remember? 1, 2, 3, 4, 5, 6, 7, 8. This one, F2, is this.
Okay, I
Covalent.
understand, but I keep forget when I like to like solve the question.
So that's why you must remember this list. This list must remember. Okay? F2, Cl2, Br2, I2, H2, N2, O2. Maybe you should write this down.
No, I can remember that, but
When you're doing, you cannot
when
remember.
I do this kind of questions, like I forget like how to transfer this to this.
Okay. Jay, you understand now? Alright. Now you understand?
I understand.
You understand, you just have to remember, is it?
Yeah.
Okay. Alright, so now we're going to move on to the next part. Okay, so molten, this one molten, is it easy or difficult to do? Difficult. Why is it difficult? Because in order to be molten, the temperature has to be really, really high. So for example, like lead-2 bromide, about 300 degrees Celsius it will melt. But for sodium chloride, it only melts at 801 degrees Celsius. Do you think my school lab can reach 801 degrees Celsius? Of course not. So instead of using molten, we do something called aqueous. So aqueous is actually quite fun. Okay, so I want you to look at page 127. Look at this one. Okay, textbook 127.
2, 7.
Okay, now you notice this one is a beaker. It's a beaker because it's an aqueous solution. So all you do is you take the salt and then you add water. And then it will dissolve lah. Okay, so let's say I use sodium chloride. Let's say I use sodium chloride. Okay. Now, for sodium chloride, if I have sodium chloride, it becomes sodium ion and chloride ions, right? Correct? Okay. But what you must understand is this also has water. Okay? This also has water. Now, water what do you think water becomes? Water becomes hydrogen ion and hydroxide ion. Okay, so what I want to ask you is, in the aqueous solution of sodium chloride, how many anions and how many cations do you see?
From which?
This one. Aqueous solution of sodium chloride, there's sodium chloride and water. How many cations are there? Two. How many anions are there? Two. Okay, so what happens is all the cations will go to the cathode. They will both go to the cathode. All the anions will go to the anode. But you can only choose one to react. Okay? You can only choose one. Alright. What I want you to do now is take a 1 minute break. Go and drink water and go and wash your face. Go.
Me?
Yes.
No, my facial expression.
You sure? Can continue? Alright. Okay. Jay, you okay? Okay. So this part, I want you to write this down. How to choose.
How to choose?
Yes. Okay. Let's do cation first. If it is group 1, 2, and 3. Okay. If it's group 1, 2, and 3, for example, sodium ion, magnesium ion, aluminium ion. You do not choose these three. You do not choose from group 1. You choose hydrogen ion instead. Okay? So that's the first rule. The first rule, if you have a choice between group 1, group 2, group 3, and hydrogen ion, you choose hydrogen ion. So in this case, who do I choose? Sodium ion or hydrogen ion? To react. Who will react? Sodium ion or hydrogen ion? Hydrogen ion. So the hydrogen ion will receive electron to become hydrogen gas. So I will see bubbles here. Bloop, 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 bloop. Hydrogen gas bubbles. Okay, please write this down. This is on that page. Okay.
Wait, what does that mean again? Group 1 to 3.
If it's a choice between group 1, group 2, group 3 ion and hydrogen ion, you choose hydrogen ion instead.
Oh.
You don't choose group 1, group 2, group 3. That means sodium ion and hydrogen, choose hydrogen. Magnesium ion and hydrogen, choose hydrogen. Aluminium ion and hydrogen, choose hydrogen. Get it? Okay, ready? Okay, get it? All right. Now, If it is transition metal. Do you remember what's transition metal? If transition metal or hydrogen, choose transition metal. For example, copper, silver. Okay? So if it's a copper ion and hydrogen, choose copper. If it's silver ion and hydrogen, choose silver. Get it? That's all. That's it. Okay, write this down. Write this down. You're like buffering like that, your brain.
Yeah. So if it's transition metal,
You choose
if
transition metal. Okay, tell me.
So if you need to choose between transition metal or hydrogen, choose transition metal.
Yes.
So the transition metal are copper and silver.
Yeah, for example, copper and silver. Nickel also can. Anything that's a transition metal. Alright? Okay. Jay, you okay? Okay, last thing. Anode. Okay, anode is easier. Okay, anode, if it is nitrate, sulfate, you never choose them. Okay? Nitrate and sulfate, never chosen. Okay? It's only between chloride, bromide, iodide versus hydroxide. That's it. Because water has hydroxide, right? Okay? It's only between chloride, bromide, iodide, and hydroxide. Okay. If it is diluted, choose hydroxide. If it is concentrated, choose chloride, bromide, iodide. If it's nitrate, sulfate, you never choose them, you choose hydroxide. So the choice is only between chloride, bromide, iodide, or hydroxide. Diluted, choose hydroxide. Concentrated, choose chloride, bromide, iodide. Okay? How do you know if it's concentrated or diluted?
Wait, we're now choosing the
Anion. To one
choosing for what?
to react lah. Only one can react.
Oh.
So hydroxide ion changes to become water, oxygen, and releases 4 electrons. If you choose hydroxide ion.
Wait, choose for react?
To react, you know, just now we did this one. We choose this one, cation, anion, like that.
Yeah.
Now you have 2 cation, 2 anion. You can only write one equation. So you must choose which one to write the equation.
Oh.
Okay, get it? Make sense? Alright. Okay, write this down. This is for anode.
Wow. So between concentrated and diluted, choose
Yes, yes. If it's diluted, you choose hydroxide. If it's concentrated, choose chloride bromide iodide.
Wait, how do we know if it's concentrated or
The
diluted?
question will say concentrated or diluted.
Okay.
Okay, let's try. When you do question, then you will know. Okay, look back at the paper. Jay, look at the paper. Look at this part here. All right, let's start. Okay, what does it say here? Jay, you okay or not?
Mm-hmm.
All right.
I'm
What
trying to
does it
make it
say here?
straight.
Sorry, what?
Just trying to make the letter straight.
Okay. So this one is diluted or concentrated? Here. Grace. Diluted. How you know? Because they wrote diluted.
Huh?
They wrote diluted. That's how you know it's diluted. Okay? So, because it's diluted, so it's diluted what? Diluted sodium chloride solution. So, it is sodium chloride. But does it have water?
No.
Yes, because it's called solution. So water. It only does not have water when it says molten. Okay? So water gives me what ion? Water gives me hydrogen and hydroxide. Sodium chloride gives me sodium and chloride, hydrogen and hydroxide. So now in the solution, I got two cation, two anion.
Choose H.
Yes. So this one, I must choose H. Hydrogen ion becomes hydrogen gas.
Choose OH.
Yes. Hydroxide ion becomes water. And for oxygen and for electron. Get it? Okay. So what will I see? I will see bubbles in the cathode and I will see bubbles in the anode. Do you understand? Okay, please write this down.
Right over the equation.
Okay. Overall equation is like this. So overall equation is a bit tricky. You have water and you have sodium chloride. Water gave you hydrogen and hydroxide. Sodium chloride gave you sodium and chloride. But both your reactions came from this. Only this one reacted, right now. Did sodium or chloride react? No. So this is also known as electrolysis of water. How we get pure hydrogen from water. Understand? Can see or not? Hydrogen, hydroxide from water becomes hydrogen oxygen. Okay? Alright, if you don't know how to do overall equation for the rest, it's okay, I will teach you. I want you to try to do this and this. Okay? Okay, do now. Do all these ones first. Jay, you know what to do?
Mm.
Okay,
Mm.
can I?
Oh.
All right. So, sodium. So the ions are the same. Here you still choose hydrogen. Did you get it correct? Jay, did you get it correct, this one?
With your cherries.
Oh. Yeah.
Mm.
Each.
It was about to like fall.
Really?
Like it was like shaking.
Okay. If it falls, we'll come out newspaper. It's going to crash into you. Okay. Now, chloride and hydroxide. Because it's concentrated, we choose chloride. Okay, so chloride becomes chlorine.
Mm.
Okay? Did you get this correct? Okay, now this part is a little bit more in skills. Okay? So we started with sodium, chloride, hydrogen, hydroxide. This is from sodium chloride. This is from water. Correct? Correct? Okay. From sodium chloride, who do we choose? Who did we choose? Chloride. Right now. Okay. From water, who do we choose? Hydrogen. So now both of them, each one is chosen. So I cannot do like this. Okay. So I have to start out with both. It has to be sodium chloride and water
Mm.
becomes chloride became chlorine. Hydroxide became hydrogen. Who do I have left? Who did not get to do anything? Sodium hydroxide. The poor sodium hydroxide is left behind. They look at each other sadly and they hug each other and they become sodium hydroxide. Understand? Wait. Balance the equation. 2, 2, 2. This is the overall equation. Okay? They don't usually ask the overall equation. Get it? You understand now? Okay. Now, Jay, can you tell me what is the formula for potassium sulfate?
Potassium sulfate.
This is sulfate, so it's
K.
K2SO4. Okay? K2SO4.
Mm.
SO4 from sulfate, K plus from potassium, hydrogen and hydroxide.
Yes.
Okay? Now you choose.
Mm.
Oh. It's OH.
Yes.
Is it the same from the?
Yes, very good. So, who do I choose? Hydrogen, hydroxide. So this is also electrolysis of water. Make sense now? Make better sense now? It's okay. It's okay. You don't have to rush it. We can have.
I remember the sulfate.
Oh, this is the list.
Yeah, but how can I remember?
Sulfate. Nah, this one you have to remember lah. Sulfate nitrate hydroxide. Okay, sulfate nitrate hydroxide. All right. And then this is electrolysis of water.
They don't give us like the list or anything.
No, they don't. They only give you periodic table. Okay, can you try and do the last three? Try, slowly try. Don't stress. Jay, are you okay? Can you manage to do? Yes? Okay. Can you describe? Is that check and see? How why not?
No, I put 2 in front of calcium bromide.
No need what? Because here already Br2, here Br2. Okay, if this one you got wrong, it's okay. They don't usually ask you this one they rarely ask you, as long as this one and this one is correct. Okay?
Wait, let me check this.
Can? Okay.
Oh yeah.
Silver nitrate. So this one is hydroxide. So this hydroxide equation you've written so many times, I'm sure you can write in your dreams also.
That's not realistic.
Okay. So let's see this silver nitrate hydrogen hydroxide. Who did I choose? Silver and hydroxide. So silver nitrate plus water become silver plus oxygen. Who is left over? HNO3. Balance the equation. 2, 4, 4, 4. Okay. Can you see that?
What's that?
Which one?
For
For HNO3. HNO3. Jay, did you get it correct? Yes? Alright. Huh? Never mind, we'll do this again next week. The overall wrong is okay. The overall is wrong is okay. Alright? Okay. Because the overall is something new. The rest, as long as the half equation is correct.
one also, like, if I don't look at the previous one,
It's okay. It's something new. Don't worry. You're not supposed to learn everything in one day, what? It's something new. We slowly do. Don't worry.
Okay, 5 minutes left.
Yes, we finished this just nice. So this is same lah. I don't write again, very lazy. Okay. So copper copper, sulfate, hydrogen, hydroxide.
Wait, can I try?
Yes, can. Try first, try first.
Hmm.
Pause. Plus O2 plus
Hmm.
HSO2.
Hmm.
Okay.
Wait.
Okay, okay.
Hmm.
Huh? Wait, what? Oh, four? Wait, four copper, SO4, four, H2.
You basically two everything except for oxygen. Okay, Jay, did you get it correct?
Hmm?
Did you get it correct? Yes? All right.
Nah.
Wait.